Hello and welcome back to Engineering Online. From level monitoring to object detection, ultrasonic sensors are being used in wide range of applications. This technology and its applications are continuously increasing and they are gaining high recognition in industrial and academic world. The main reason behind their wide recognition is their smaller size, easy integration, high sensitivity, high power, high accuracy and high frequency. Plus they are quite easy to use and they are an inexpensive option. Most commonly, they are used for presence detection, drink filling machines, anti-collision detection, box sorting, etc. In this tutorial, we are going to interface a HCSR04 ultrasonic sensor with Arduino Uno. This sensor will read the distance to an object and then display it on the serial monitor. Let's have a quick introduction of HCSR04 first. The HCSR04 ultrasonic sensor uses sonar to determine distance to an object like bats do. It offers excellent non-contact range detection with high accuracy and stable readings in an easy-to-use package. Its range of detection is from 2 cm to 400 cm or 1 to 13 feet. Its operation is not affected by sunlight or any black material. It comes in a complete package with control circuit, ultrasonic transmitter and receiver module. It works by sending sound waves from the transmitter, which then bounce off from an object and then return to the receiver. You can determine how far away something by the time it takes for the sound wave to get back to the sensor. There are total 4 pins in HCSR04. First one is VCC. You need to provide plus 5 volt at this pin. Then we have trigger pulse input. It's a trigger pin where we need to provide a trigger after which sensor emits ultrasonic waves. Then we have echo pin. When ultrasonic waves emitted by the transmitter hit some object, then they are bounced back and are received by the receiver. And at that point this echo pin goes high. Then we have ground pin. We need to provide ground to this pin. A signal of plus 5 volt is sent over to trigger pin for around 10 microseconds in order to trigger the sensor. When ultrasonic sensor gets a trigger signal on its trigger pin, then it emits an ultrasonic signal from the transmitter. This ultrasonic signal then goes out and reflected back after hitting some object in the front. This reflected signal is then captured by the receiver. As the sensor gets this signal, it automatically makes the echo pin high. The time for which the echo pin will remain high depends upon the reflected signal. So what we need to do is we need to read this time for which the echo pin is high. Now let's connect this sensor with Arduino Uno. Connect VCC pin to 5 volt pin of Arduino. Then connect trigger pin to pin 9 of Arduino. Now connect echo pin to 10 pin of Arduino. And in the end connect ground pin of sensor to ground pin of Arduino Uno. Now let's do the same connections on hardware also. Once all the connections are completed, now we have to write the Arduino sketch. First of all, I have to define pin numbers as constants. Define trigger pin as pin 9 and echo pin as pin 10. Then I have to define variables, that is long variable named as duration for the travel time that is received by the sensor, and an integer variable for distance calculation. In the setup, define trigger pin as output and echo pin as an input. Start serial communication to display the results on serial monitor. In loop, first I have to make sure that the trigger pin is low, so set this pin to low for around 2 microseconds. Now generate the ultrasound wave, set this pin to high, state for 10 microseconds. And then set it back to low. Pulse in function is used to read the travel time and save it in the variable duration. As you can see that there are two attributes of pulse in function. First one is the name of the pin and second is the state. It can be either high or low. If you write high there, that means the function will wait for this pin to go high. This pin would be high due to received sound wave and timing will be started. This time would be recorded until the pin goes low again. So in result, the length of the pulse is recorded in microseconds. Now multiply this duration by 0.034 and divide by 2 to calculate the distance. In the end, print this distance on serial monitor. Coding is completed now. Compile it and check if there are any syntax errors. Then upload it on Arduino Uno and see the results. Now try this code on your own and provide your valuable feedback in the comment section. I hope that you must have learned a lot from this video. You can do some modifications in the code and display the results on LCD also. That was all for today. Do like this video and share it with your friends. Subscribe to our channel for more interesting and informative videos. Thank you.